Welcome back to this math channel. Today, let us discuss about geometric series. Let us have a recall of an important concept. In finding the nth term or the general term of a geometric sequence, we use a sub n equals a sub 1 times r raised to n minus 1, where n is the number of the term, a sub 1 is the first term, and r is the common ratio. For example, to find the fifth term of geometric sequence where the first term is 10 and the common ratio is 1/2, we write a sub 5, that is the fifth term, equal to a sub 1 times r raised to 4, that is 5 minus 1. Substituting a sub 1 equals 10 and r equals 1/2, we have 10 times 1/2 raised to 4. 1/2 raised to 4 is 1 over 16. So we have 10 times 1 over 16. Multiplying, we get 10 times 1 is 10 over 16. Simplifying this resulting fraction, therefore, the fifth term, or a sub 5, is equal to 5 over 8. Now let us proceed to the definition of geometric series. A geometric series is the indicated sum of the terms of a geometric sequence. The series 3 plus 6 plus 12 plus 24 plus 48 is a finite geometric series because there is a limited or finite number of terms. While the series 1 plus 3 plus 9 plus 27 plus and the pattern continues is an infinite geometric series since there is an unlimited or infinite number of terms. To find the formula for the partial sum S sub n of a geometric series, multiply S sub n by r and subtract the product from S sub n. Let S sub n be the partial sum of a geometric series. Then we have S sub n is equal to a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus a sub 1 r cubed plus, and the pattern continues until the nth term, that is a sub 1 times r raised to n minus 1. Now multiplying all terms of this equation by the common ratio r, we'll have r times s sub n is equal to a sub 1r plus a sub 1r squared plus a sub 1r cubed plus, and the pattern continues until the nth term, that is a sub 1 times r raised to n. Subtracting the two equations, we'll have s sub n minus r times s sub n. On the right hand side of the equation, we'll have a sub 1. A sub 1r minus a sub 1r is 0. A sub 1r squared minus a sub 1r squared. A sub 1r cubed minus a sub 1r cubed, 0. And the pattern continues until a sub 1 times r raised to n minus 1, that will be 0. The last will be a sub 1 times r raised to n. So on the right hand side, we have a sub 1 minus a sub 1 r raised to n. Factoring the common monomial on both sides of this equation, on the left hand side we'll have s sub n times the quantity 1 minus r equals, on the right hand side, a sub 1 times the quantity 1 minus r raised to n. Dividing both sides by 1 minus r, will have the formula for the partial sum S sub n of a geometric series. That is a sub 1 times the quantity 1 minus r raised to n all over 1 minus r. In here, S sub n is the partial sum of the geometric series. A sub 1 is the first term. R is the common ratio. And n is the number of the term, or number of terms. Let us have an example. Find the sum of the first 5 terms, S sub 5, of the geometric series 2 plus 8 plus 32 plus, and the pattern continues. From the formula, S sub n is equal to A sub 1 times 1 minus r raised to n all over 1 minus r. We need to get A sub 1, r, and n from the given geometric series. A sub 1 is equal to 2, and r is equal to 8 over 2, that is equal to 4. We can check by getting the ratio 32 over 8, that is 4. And n is equal to 5, since we're looking for the partial sum S sub 5. Substituting the values, we have S sub 5 is equal to A sub 1, that is 2, times 1 minus r, that is 4, raised to n, that is 5, all over 1 minus 4. 4 raised to 5 is 1024, so we have 1 minus 1024. 1 minus 4 is negative 3. So we have 2 times 1 minus 1024 is negative 1023, all over negative 3. 2 times negative 1023, that is negative 2046. And negative 2046 divided by negative 3, we have S sub 5 is equal to positive 682. A second formula for finding the partial sum S sub n of a geometric series can be derived from the first formula. From S sub n is equal to A sub 1 times the quantity 1 minus r raised to n all over 1 minus r. By distributive property, we have S sub n is equal to A sub 1 minus A sub 1 r raised to n all over 1 minus r. We know that the n term of a geometric sequence is given by A sub n equal to A sub 1 r raised to n minus 1. If we multiply both sides of this equation by r, we have r A sub n is equal to A sub 1 r raised to n. Now substituting A sub 1 r raised to n is equal to r times A sub n. To the partial sum, we have S sub n is equal to A sub 1 minus A sub 1 r raised to n, that is equal to r times A sub n all over 1. A sub 1 is the first term, r is the common ratio, A sub n is the nth term, and n is the number of terms. Let us have another example. In a geometric series, A sub 1 equals 9, r equals negative 2, and A sub 8 equals negative 1152. Find S sub 8. From the second formula, we have S sub n is equal to a sub 1 minus r times a sub n all over 1 minus r. Substituting a sub 1 equals 9, r equals negative 2, and a sub 8 is equal to negative 1152, we'll have s sub a is equal to 9 minus negative 2 times negative 1152 all over 1 minus negative 2. Negative 2 times negative 1152 is 2304. In the denominator, we have 3. 9 minus 2304 is negative 2295 divided by 3. S sub 8 is equal to negative 765. A geometric series can also be written using the sigma notation. Let us have an example. Find the sum of the geometric series, summation of 7 times 2 raised to n minus 1 from n equals 1 until 9. Using the first formula for the partial sum of the geometric series, we have s sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. To get a sub 1, we have n is equal to 1 from the summation notation. So we have 7 times 2 raised to 1 minus 1. 1 minus 1 is 0, and 2 raised to 0 is equal to 1. Therefore, a sub 1 is 7. Let us have the second term. That is 7 times 2 raised to 2 minus 1. 2 minus 1 is equal to 1, and 2 raised to 1 is equal to 2. Therefore, a sub 2 is equal to 7 times 2, and that is 14. Let us get the third term so that we can be sure of the common ratio when we solve it. So let us have a sub 3. That is when n is equal to 3. So we have 7 times 2 raised to 3 minus 1. 3 minus 1 is 2, and 2 raised to 2 is 4. Therefore, a sub 3 is equal to 7 times 4, that is 28. Hence, we have the geometric series written as 7 plus 14 plus 28 until the 9th term, that's a sub 9. From here, we can get that r is equal to 14 over 7, that is equal to 2. We can check 28 over 14, that is also equal to 2. Hence, substituting the values to the formula for the sum of geometric series, we have s sub 9 is equal to a sub 1, we have 7, times 1 minus r, that is 2 raised to 9. All over 1 minus 2. 2 raised to 9 is 512. So we have 7 times 1 minus 512. We have negative 511 over negative 1. 7 times negative 511 is negative 3,577 divided by negative 1. Therefore, the partial sum of the first 9 terms in the geometric series is 3,577. This time, let us have some practice exercises. In the practice exercises, you will be given 15 seconds for each item. You may pause the video if you need more time to answer and play it again to check whether your answer is correct. Let us have number 1. Find the sum of the first 7 terms, s sub 7, of the geometric series 1 plus 2 plus 4 plus 8 plus, and the pattern continues. Go! Time is up. Let us see the answer. From the formula, S sub n is equal to a sub 1 times the quantity 1 minus r raised to n all over 1 minus r. We need to get a sub 1, r, and n from the given series. So we have a sub 1 is equal to 1, r is equal to 2 over 1, that is the second term, over the first term, that is equal to 2. We can check by getting the ratio 4 over 2 and 8 over 4. So r is equal to 2. And n is equal to 7 since we are looking for the partial sum s sub 7. Substituting the values, we have s sub 7 is equal to 1 times the quantity 1 minus 2 raised to 7 all over 1 minus 2. 2 raised to 7 is 128. So we have 1 times the quantity 1 minus 128. 1 minus 2 is negative 1. 1 minus 128 is negative 127. Divided by negative 1, therefore s sub 7 is equal to 127. This exercise number 2. In a geometric series, a sub 1 is equal to negative 1, r is equal to negative 2, and a sub 10 is equal to 512. Find s sub 10. Go. Let us see the answer. From the second formula, a sub n is equal to a sub 1 minus r times a sub n over 1 minus r. We have a sub 1 is equal to negative 1, r is equal to negative 2, and a sub 10 is equal to 512. So we have s sub 10 is equal to negative 1 minus negative 2 times 512 over 1 minus negative 2. Negative 2 times 512, that is negative 1024. So we have negative 1 minus negative 1024 all over 3. So we have s sub 10 is equal to negative 1 plus 1024 over 3. Negative 1 plus 1024 is 1023 over 3. Therefore, s sub 10 is 1023 divided by 3. That is equal to 341. Number 3. Find the sum of the geometric series, summation of 3 times 3 raised to n minus 2 from n equals 1 until 7. Go. Time is up. Let us answer. Let us get the first few terms of this geometric series. When n is equal to 1, we have a sub 1, that is equal to 3 times 3 raised to 1 minus 2. So we have 3 times 3 raised to negative 1. So that will be equal to 3 over 3. And a sub 1 is equal to 1. Let us have a sub 2. That is when n is equal to 2. 3 times 3 raised to 2 minus 2. So we have 3 times 1. Therefore, a sub 2 is equal to 2. Let us have a sub 3. That is 3 times 3 raised to 3 minus 2. So a sub 3 is equal to 3 minus 2 is 1, and 3 raised to 1 is 3. So we have 3 times 3, 9. Hence, we can get the common ratio R, that is equal to a sub 2 over a sub 1, that is equal to 3. We can check by the ratio a sub 3 over a sub 2, that is 9 over 3, also equal to 3. Now we can write the formula for the first 7 terms of this geometric series. So we have S sub 7 is equal to a sub 1, that is 1, times 1 minus R, that is 3 raised to 7, all over 1 minus 3. 3 raised to 7 is 2,187. So we have 1 times the quantity 1 minus 2,187. 1 minus 3 is negative 2. So we have 1 times 1 minus 2,187 is negative 2,186 over negative 2. Therefore, S sub 7 is equal to negative 2,186 divided by negative 2. That will be positive 1,093. That will be all. Thank you for watching. Please subscribe for more math lessons.